Okay, so Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. By the way, saja on purpose besarkan sikit screen untuk tengok muka saya dulu, lepas tu baru kita tengok screen Okay, so I think for today, morning. Okay, so for today, basically we gonna do 1.1, 1.2, as well as 1.3, the technique of integration as well. But for the technique of integration, I'm only going to cover up until integration by part. So only until integration by part. And then for integration by using partial fraction, we're going to continue for next week. So nanti maybe kita akan take 5 kot. After I finish this lecture, I think before I start with 1.3, we're gonna have a break for maybe 5 minutes will do, I think. And then we're gonna start with 1.3. Okay, so now saya tukar balik jadi skrin yang besar, muka saya kecil balik. And then we're gonna start. Kenapa nampak macam pecah? Kamera pecah kot. Tak tahulah. Okay, never mind. Alright, so today this is a new topic for the second semester. Well done everyone. You guys have survived the first semester. So it's time for the second semester. So for the second semester, we have 10 chapters. As usual, 10 chapters. So this is the first chapter, which is integration. So for those who are interested to continue in engineering and etc., integration and differentiation is something that you must know. So integration ni adalah topik yang sangat penting lah untuk kita belajar sebenarnya. Okay, so with that, without further ado, let us start then. So I'm gonna cover 2 things for this lecture. So we got 2 hours, right? For the first hour, we're gonna spend 1 hour on integration of function. So this is mostly on the basic rule of integration, and then the integration of trigonometric functions. So we're gonna see what are the trigonometric functions that we can easily integrate, and what can we do if we have something with a square or a double angle, and perhaps something to change from product to sum as well. Okay, so now the first one, you should be able to relate the integration and differentiation. So we have learned differentiation in the first semester. So you should be able to integrate within these two. And then to define the basic rule of integration, so we do have a few basic rules of integration. So those are the things that you need to know. And then find the integral of the exponential 1 over ax plus b and a to the power of bx plus d. Okay, so one thing that we should take note over here, do you see the power? So the power for this one is a linear. What do we have in our denominator? This is also a linear. This is a to the power of bx plus t. That is also a linear. So that is the reason why we're going to call this as the basic rule of integration. So that means we only have something with a linear. Okay, next we're going to cover how to find the integral of the form f prime of x over fx dx. So we can easily spot, oh, we do have something in our denominator. Oh, wait, but if I differentiate my denominator, I'm going to get its derivative on top. So that is why or when we use this formula. So for the second one, we have f prime of x e to the power of fx dx. So as you can see, for the power of the exponent, if let's say we do differentiate the power for the exponent, we're going to get whatever we have in front. So that means we can use this formula as well. So for this one, you have a function. So a function with a power, but if let's say you do differentiate this function, you're going to end up with its derivative in front. So that is the reason why we are using this formula. And then you should know how to find the integral of trigonometric functions. So we have a few basic rules of trigonometric function. We have sine, we have cos, but this time we don't have tangent. We have secant square. So for integration, we learn how to integrate secant square. not tangent. Kalau tangent nanti dia kena pakai teknik lah. So for the basic rule of integration, it's only involve sine, cos, as well as second square. So those are the three things that you need to remember. Okay, so what is integration? Integration is actually the reverse of differentiation and also known as the antiderivative. Okay, so that means if we do integrate fx with respect to x, we are going to end up with fx plus with a constant c. Okay, so what do we mean? This is actually the reverse process of derivative. Okay, so if let's say we do differentiate fx, we are going to get the small f. So that means if you do integrate on both sides with respect to x, so this one, integration is the entire of derivative. So you're going to cancel this as well as d over dx. So that is how you end up with fx. And for this one, this is simply fx dx. And then we have to plus with c because every time we differentiate a constant, we're gonna get a zero. So sebab tu dia kena ada constant lah bila kita integrate something. We must always write down a c. Small c or cap c, it doesn't really matter. But normally we use a c. Okay, so those thing yang kita panggil, kadang-kadang ada orang panggil ular lah apa kan. So those are actually the integral sign. So every time we do something with integration, do remember to always write down the integral sign. Integral sign, integrand, variable of integration, the integral, and the constant of integration. Okay, so one thing that you should take note, every time you integrate, those integral as well as a dx, a dy or dz that actually correspond to the variable that you have, those are a pair. So dia pair sepasang. Sepasang maksudnya kalau kita tulis integral je, kita kena tulis lah kat belakang dx ke, dy ke, dz ke, kena tulis, tak boleh skip. Kalau skip tu dia kira macam tak valid lah. Mesti kena tulis dua-dua, a pair. Satu pasang lah. Jangan suka-suka hati ubah pula. Okay, next. Okay, so these are the basic rule of integration. We do have a few basic rules of integration. So the first one, if let's say you have some constant, integrating some constant, it will simply become kx plus c, where k is a constant. Okay, so this is the power rule. So if you have to integrate x to the power of n dx, what will happen is that we're going to add 1 to the power and then divide with its new power and then plus with c. But there is one restriction over here. The power shouldn't be negative 1. So why is that? Excuse me. Okay, so if you refer to your denominator over here, we actually have n plus 1. Let's say if we have n equal to negative 1, then it will become negative 1 plus 1, which is simply equal to 0. But this is in our denominator, so we cannot let our denominator equal to 0. So that is the reason why we are having this restriction. Our n cannot be equal to 0. N cannot be equal to negative 1. Otherwise, n plus 1 will become 0 and it will become undefined. Sebab kita bahagi dengan kosong, kita dapat infinity kan. So we must always avoid that. So for the basic rule of integration, always remember n cannot be equal to negative 1. If n is equal to negative 1, we're going to use some special rule for them. Okay, so this is actually a special power rule. So we got ax plus b to the power of n. So one thing that you should take note, if you have a highlighter, please highlight this one. So this is only a linear. This formula is only true for a linear. Linear. One more time, I repeat, this formula is only true when it is a linear. Okay, so we have ax plus b to the power of n. So what happened? We're going to copy down the function first, ax plus b, but instead of n, we're going to add 1 to the power. So it will become n plus 1. Divide by the new power. So we are going to divide by n plus 1. And then we're going to take the coefficient of x. So you're going to divide by the coefficient of x. So kalau kat sini, coefficient of x is a. So we are going to divide by a. And again, we do have one restriction for the power. N shouldn't be equal to negative 1. Otherwise, again, we're going to have 0 in our denominator and everything will be undefined. So again, I repeat, this formula is only for a linear function. If you don't have something with a linear, we're going to use some technique for them. Okay, so that is the third one. The fourth one is that if let's say you do have some constant, right? What you can do is you can easily bring the constant outside of the integral before you integrate them, of course. Okay, and then if let's say we have fx plus minus with gx, so we have a sum inside our integral. So we have 1 plus 2x or 2x minus 1 and etc. So plus or minus. What you can do is that you can easily separate those into two function, those into two integral, and then we can integrate each of them. But do remember when you are separating them, we do have to write them down in the correct pair. Correct pair tu maksudnya yang ni lah, dua ni. So this is for fx and then another pair for gx. So dia mesti kena pair integral dengan dx tu dia kena datang sekali. So sometimes we don't write down dx. It actually correspond to this variable. Kalau kat sini variable dia z, then dz lah. Variable dia y, dy. Variable dia t, dt and etc. So you need to always follow the variable. Okay, so now let us go to the first example. Find the following integral. So we have x cubed plus 2 to x to the power of 4, 3x plus 2 to the power of 7, 3 set x plus 3 over x to the power of 4 dx. Okay, so let us try to do them very, very carefully and slowly, of course. Sebab ada yang macam baru nak recap kan integration, ada yang baru belajar integration. So we're gonna go a bit slowly. Okay, now A. So we have x cubed plus 2 dx. So based on the basic rule of integration, we're going to see which formula is suitable for them. Okay, so I have x cubed. So that means I can use the formula for integrating x to the power of n. So I can actually use the formula for integrating x to the power of n dx, where it will become xn plus 1 over n plus 1 plus c. Integrating 2, that is actually a constant, so we can actually use the formula for the constant. Okay, so x cubed. Adding 1 to the power, so 3 plus 1, it will become x to the power of 4. Divide by the new power, so we're going to divide them by 4. And then plus, so integrating 2 now. So integrating those constant, we simply write down the x. So kita tengok variable kat belakang ni lah, variable the x, so we're going to simply write down x. Okay, so it will become 2x to the power of 1 and then plus with c. So kita combine semua constant pergi dekat belakang sekali lah. Kalau ikut dekat sini ada satu C, sini ada satu C kan. So kita combine dua-dua jadi satu C dekat sini. Tulis sekali je lah constant tu. Okay, so again, I do a bit of recap for this question. So we're gonna add 1 to the power. This is a basic power rule. Add 1 to the power. Divide by the new power. This is simply a constant for the 2. So we simply write down x. So 2x plus with c. Okay, continue. So we got 2x to the power of 4 dx again. As we can see, this is something with a power. So we can actually use a power rule for them. So adding 1 to the power, divide by the new power. So it will become 2x to the power of 5 over 5 plus c. So you're going to add 1 to the power. So it will become 5 and 5 over here. So those are the b. So now c. So we got 3x plus 2 to the power of 7 dx. Integrate 3x plus 2 to the power of 7 dx. So do check which basic rule do you want to use. So this is actually for integrating ax plus b to the power of n dx. So we can actually use this formula. Why? Because this is a linear. So we can actually use this formula because the function inside that is a linear. So we're going to add 1 to the power, divide by the new power, and then I'm going to divide by the coefficient of x. Okay, so what will happen? So we are going to get 3x plus 2 to the power of 7 plus 1, which is 8, over with the new power, 8. And then we're going to simply divide with the coefficient of x. So this is your x, the coefficient is 3. So we are going to divide by 3. Okay, so 3x plus 2 to the power of 8 over 3 times 8 plus c. And then you can easily simplify this. 3 times 8, that is actually equal to 24. So it will become 3x plus 2 to the power of 8 over 24 plus with C. Done with C. So now D. Okay, so we got 3x to the power square root of x. So 3 square root of x plus 3 over x to the power of 4 dx. Okay, so now we're gonna use the power rule for them, but we have to be extra careful. We need to really check what is the power for the x. So I'm gonna bring the power up first. So we are going to get 3x to the power of half. So instead of having a set x, I'll change it to x to the power of half. And then instead of having 3 over x to the power of 4, I'm going to bring x to the power of 4 up. So it will become x to the power of negative 4. Kalau ada constant tak ada masalah kita boleh biar je constant tu kat bawah. So for example, if let's say you have 2 over let's say 5x, then only the x, you're going to bring them up. So this one will become 2 over 5 x to the power of negative 1. So leave the constant, you only bring the x up. Okay, so now we're going to use the power rule for them. Adding 1 to the power, divide by the new power, and then we're going to simplify. Okay, so adding 1 to the power, so half, it will become 3 over 2. Divide by the new power, so we're going to divide by 3 over 2. And then x to the power of negative 4 plus 1, so it will become negative 3. Be extra careful if you are using something with a negative. Be extra careful, always recheck. Sebab negatif ni kadang-kadang ada setengah orang dia macam allergy sikit. So dia kadang-kadang kalau tambah pun dia tolak juga. So be extra careful if you have to use your calculator. If you have to. So negative 4 plus 1, it will become negative 3. So negative 3 x to the power of negative 3 over negative 3 plus with C, and then we can simplify them. So we have 3 over 2 at bottom, so I'm going to take the reciprocal for that. So it will become 3x to the power of 3 over 2 times with 2 over 3 plus with 3 x to the power of negative 3 over negative 3 plus with C, and then we're going to simplify them. 3 and 3 will be cancelled out. 3 and 3 will be cancelled out. So what do we have left is simply 2x to the power of 3 over 2 minus 1 over x cubed plus with C. Okay, so done with this. Okay, next. Alright, so now this one not really basic, tapi kalau untuk saya nasihatkan masukkan je formula ni dalam basic rule. So at first when you want to start with integration, it's gonna be a little bit hard, but don't worry. For me, I prefer to write down all the formula for the basic rules first, and then whatever that is not inside the basic rule, I'm gonna use some technique for them. So yang ni masuk dalam basic, pastikan nanti buat list dulu dalam basic rule. That will help you a lot actually. Okay, so the first one, we got an exponential. So e to the power of ax plus b. Again, I remind you, the power for this should be linear. 1 over ax plus b. Again, in our denominator, I only have a linear. A to the power of bx plus d. Again, that is always a linear. So always remember, these are the very basic rule of integration. So those are always for a linear function. Okay, so if we have to integrate e to the power of bx plus d, suddenly dia tukar huruf tapi tak apalah. E to the power of bx plus d, so it will become e bx plus d over b. So we're going to copy down the exponent, and then we're going to take the coefficient of x. So we will divide with the coefficient of x. In this case, we will divide them by b plus with c. And then this one, we got 1 over bx plus d. So it will become 1 over the coefficient of x, which is b. So 1 over b. And then we got a ln over here, ln of bx plus d. So why do we have to put the modulus sign? Because we need to make sure that everything that is behind the ln, they should always be positive. Sebab ln dia tak boleh nombor yang negatif kan. Sebab tu kita akan sentiasa letak modulus lah. Okay, and then another one is that a to the power of bx plus d dx. So copy down the exponential function first. A bx plus d. And then you're going to divide with the coefficient of x, which is b, but this time you have an extra thing which is called the ln of the base. So ln of a. Actually dekat sini pun ada ln of the base. So kat sini ln e, but the whole world know, right? Everyone know ln e is actually equal to 1. So we don't really write them down. Tapi sebenarnya ini formula yang sama saja. Okay, next. Right, so now let us find the following integral. So let us go to each of the question and let's see what happened. Okay, so the first one, we got e to the power of 3x plus 2. Again, I will remind you again and again, this formula, we can actually use the basic rule of integration because we have a linear as the power. Okay, so what happened? We're going to copy down the exponent first and then we're going to divide by the coefficient of x. Okay, so copy down the exponent and then simply refer to your x. What is the number in front of the x? We're going to divide them by that number. So it will become e to the power of 3x plus 2 over 3 plus with c. Okay, so copy down the exponent, divide by the coefficient of x. Okay, next. So we got 1 over 4x plus 1 dx. Again, this is the basic rule because below here, behind the belakang, below here, bawah. So below here, we have 4x plus 1, which is exactly a linear function. So again, a linear function. So I can use this formula. So it will become 1 over the coefficient of x ln of ax plus b. So it will become 1 over 4. So the coefficient of x is 4. So 1 over 4 ln of 4x plus 1 and then plus with a c. Okay, so done with b. So now c. So we got 6 to the power of 3x plus 4 dx. Again, this one, we can actually write them down as the basic rule because the power is a linear. So, nampak macam bosan kan? Miss Asyik sebut je linear, linear, linear. But I want to put some emphasis. Okay, so now we're going to copy down. So copy down everything first and then we're going to take the coefficient of x, which is 3, and then ln of the base. So the base is 6. Okay, so it will become 6 to the power of 3x plus 4 over the coefficient of x, which is 3, and then ln of the base, ln 6 plus c. Done. Okay, next. Integral of the form f prime of x over fx, f prime of x e fx dx, and then f prime of x fx to the power of n dx. So kalau tadi kita tengok everything is about a linear function, right? So we got e to the power of ax plus b ataupun 1 over ax plus b and then ax plus b to the power of n. So in this time, we don't have a linear in our denominator, or we don't have a linear in our exponent, or we don't have a linear inside the power. But what we can say is that we can easily see its derivative. So kalau kata kita differentiate je function tu, kita boleh terus dapat derivative dia. So we can actually simplify them quite easily. Okay, so what happened if you have f prime of x over fx? So when you refer to your denominator, suddenly that aha moment when you can easily find out your derivative on the top, then it will become ln of fx plus c. So if let's say you have e to the power of fx and then when you do differentiate your denominator, you're gonna get your denominator, but your power, sorry. So e to the power of fx, you're gonna differentiate your power and then that aha moment again, you're gonna get your derivative. So we can easily use this formula. And then another one, you got a function with a power. So this time dia bukan linear. But when you differentiate this function, you're going to get its derivative in front. Then, we can use this formula. Okay, next. Right, so now find the following integral. So we're going to see each of them and then let's see either the first form, second form, or the third form. Okay, so for the first one, so we got 8x. We have to integrate 8x over 4x squared plus 5 with respect to x. Cara baca. Okay, so integrating 8x over 4x squared plus 5 with respect to x. So this is with respect to x. Okay, so now, where is our fx? At the top or at the bottom? So kalau kita tengok power, nanti kalau differentiate power dia kena makin rendah kan? So we kena refer to our denominator. Okay, so now I know I can use the formula for f prime over fx because if fx is my denominator for x squared plus 5, if I differentiate for x squared plus 5, I'm going to get 8x straight away. So this one, I can easily write them down as f prime. This one is my fx. So that means I already have them in this form. So dah ada dia dalam bentuk yang inilah. So we can easily write down the answer. So this is ln of fx plus with c. So this is ln of your denominator for x squared plus 5 plus c. So ini kalau kita nak shortcut sikit lah. So formula ni untuk shortcut. Okay, the second one. We have to integrate 6x e to the power of 3x squared plus 4 dx. Okay, so now referring to the formula. So if let's say we have to integrate f prime of x e fx dx, it will simply become e fx plus c. So now let us see, can we get them in this form? Okay, so now referring to the power, so that one will become our fx. So fx is equal to 3x squared plus 4. So if fx is equal to 3x squared plus 4, then if I differentiate fx, I'm going to get 6x. So that means I can easily write them down in the form of f prime and e to the power of fx. So I can easily write them down in this form. So I can use the formula straight away. So it will simply become e to the power of 3x squared plus 4 plus c. So now, for the last one. Okay, so we got 6x squared, 2x cubed plus 1 to the power of 4 dx. So we're going to see if we can fit them into this formula. Okay, so we're going to refer something with a power first. That one will become our fx. So this is something that has a power, a function with a power. So if let's say this is our fx. So if fx is 2x cubed plus 1, have a guess. If you differentiate 2x cubed plus 1, can you get 6x squared? So the answer is yes. If you do differentiate 2x cubed plus 1, you are going to get 6x squared. So that means we can easily use this formula. So we can easily write them down in the form of f prime and fx to the power of n. So what will happen is that we're going to copy down the function, add 1 to the power, divide by the new power, and then plus with c. So it will become 2x cubed plus 1 to the power of 5 over 5 plus with c. So ini kita macam perfect condition lah. When we differentiate those function, we can get its own derivative inside. But what happened if we couldn't get its derivative inside? So that is why you have to learn 1.3. So we're gonna go to that part later. So kalau kata kita tak, katalah dah differentiate, alah tak dapat. Nak kata apa lagi? So tak boleh guna basic, that means we have to use some technique. So dia ada banyak teknik lah. So that is the reason why we have to learn a lot of things for integration. Okay, so now those are a few integration that can lead to logarithmic function. So if we do differentiate 1 over x dx, so this one it will become ln of x plus c. So in your list of the basic rule of differentiation, don't forget to write down this one as well. So integrating 1 over x dx, it will become ln x plus c. Integrating 1 over ax plus b, it will become 1 over a ln ax plus b plus c. Integrating f prime of x over fx dx, it will become ln of fx plus with c. So yang ini lagi sekali kita fokus dekat bahagian mana x tu. X is actually in our denominator. So that is how we can get a ln. So those are the basic rules. So we need to remember those basic rules. Okay, next. Alright, so find the integral of trigonometric function. So this one is also something that is very basic. So we got to learn 3 trigonometric function: sine, cos, as well as secant square. So sine, cos and secant square. So we don't have tangent. What if we don't have tangent? Dan dia tak masuk dalam basic lah. Kalau dia tak ada dalam ni, dia bukan basic. Tu je. Apa lagi ya? So sine is not here, cos is not here. Sine is here, cos is here. Tangent is not here. As well as sine square pun tak ada. Cos square pun tak ada. So we're gonna see later. Okay, so what happen if you do integrate cos? So integrating a cos, so it will become 1 over a sine of ax. Okay, so this one not necessarily ax. So you can have cos of ax plus b as well. So cos of ax plus b, if you do integrate them, it will become 1 over a sine of ax plus b plus with c. So kalau untuk saya, basic saya akan tulis dengan constant sekali lah. Sebab mudah sikit. So if I want to write this down in my basic rule of integration, normally I'll modify the angle a little bit so that it become ax plus b. Okay, so cos of ax, so simply take the coefficient of x, so you're going to divide by that. So 1 over a sine of ax plus with c. So those are when you integrate a cos, it will become positive of sine. But when you integrate a sine, it will become a negative cos. So sine of ax, it will become negative 1 over a cos ax plus with c. And then the third one is that if we have to integrate secant square of ax, it will become 1 over a tangent of ax plus with c. So yang ni angle plus c. Okay, so done with this formula. So let us refer to the example. Okay, so find the following integral. So we have a cos, we have secant square, we have sine. Okay, so now I'll give you 1 minute, just a quick look at the question and then simply answer them. So I'll give you 1 minute for you to try them. Boleh saya minum air jap. So do have a try. So 1 minute starting from now. Where's my timer? Okay, 1 minute. By the way, is everything good so far? Kat sini gelap lagi, so saya kena buka lampu. Jadi kalau dah ni boleh buka. Langsung. Dah cerah dah ke? Cerah dah kot. Enam, lima, empat, tiga, dua, satu. Hush. Scary bunyi dia. Okay, so done everyone? Siap dah ke? Siap dah? Asalnya saya nak buka Google Meet tapi sebab saya takut tak muat ramai-ramai. So sebab tu pakai yang ni je lah macam biasa. Kalau tak rasa je nak buat Google Meet je, syok sikit. Dah lama cakap tak ada respon. Tak apalah, next week ada respon. Okay, hopefully you guys are done. So now let us start with the example. Okay, so integrating a cos of 2x dx. So integrate a cos, it will become positive sine. Okay, so it will be 1 over the coefficient of x. So 1 over the coefficient of x and then sine of ax and then plus with c. Sikit lagi. So tak apa, saya buat yang a dulu and then we're gonna wait a little bit. Okay, so 1 over a sine ax plus c. So 1 over, so the coefficient of x is simply 2. So it will become 1 over 2. 1 over 2 sine of 2x and then plus with c. Okay, 1 over 2 sine 2x plus c. Dan Miss line slow. Agak lah. Bukan awak je, saya pun. Sebab saya rasa gambar saya macam tak clear. Tapi tak apalah. Right. Done with A. Ni slow dah ni. Done with A. Now B. Okay, so B. We got 3 second square 4x plus 2 sine 7x dx. So we're going to refer to the formula. So we got a second square. So referring to the basic rule. So for the second square, what is the formula? And then we have a sine over here. What is the formula? So we're going to write down the formula first. So if we have second square, integrating second square ax dx, so it will become 1 over the coefficient of x, tangent of ax plus c. And then for the second one, if we integrate a sine, it will become negative 1 over a cos of ax plus c. Okay, so integrate this one first. Kalau nampak constant, constant tu keluarkan je dulu. And then let us integrate second square. So integrating second square, 1 over a, so 1 over coefficient of x, which is 4. So 1 over 4, tangent of 4x. And then plus 2. And then integrating a sine. So integrate a sine, it will become negative 1 over the coefficient of x. So negative 1 over 7. Instead of a sine, it will become a cos. Cos of 7x plus with c. Now we're going to simplify it a bit because we can see some constant here, some constant here. So we can easily multiply them. Constant here, we can actually multiply them as well. So it will become 3 over 4 tangent of 4x minus 2 over 7 cos of 7x and then plus with a c. Done. Okay, so this one we have sine, cos and second square. Very basic. Okay, so now what happened if we use a double angle formula? Sometimes we need to use a double angle formula in order to modify them into a basic rule. So kadang-kadang kita nampak dia macam payahnya. Tapi sebenarnya kalau kita guna double angle formula, it will be very simple actually. So for example, if let's say you have to integrate cos square ax. So bila nampak cos square tu mungkin macam nak pakai fx kuasa n tu tak boleh kan, tak ada derivative kan. So nanti macam tak tahu nak guna apa. So actually we can modify cos square to become 1 plus cos 2ax over 2. So this one, please write them down again in the basic rule. So if you have cos square, you can easily modify them to become 1 plus cos of 2ax over 2. And then if you have sine square of ax, that is 1 minus cos of 2ax over 2. And another one, if let's say you have a multiplication between a sine and a cos, so we can actually use the formula for double angle using the sine. So sine ax cos ax. So they are having a similar angle over here. So sine ax cos ax. Again, something that you should take note. The angle are similar. The angle is the same. So that is how we can use the double angle formula. So it will become sine of 2ax over 2. Nanti 2 dengan 2 tu jangan cancel lah. No. Don't cancel. Memang tulis macam tu je. Sine of 2ax over 2. Or you can easily write them down as 1 over 2 sine of 2ax. Jangan suka-suka cancel lah. Okay, next. Find the following integral. So we have sine square of 2x and then sine of 3x cos of 3x. Okay, so sine square, we can actually use the double angle formula for them. So we're going to change it into the formula of 1 minus cos of 2ax over 2. And then sine of 3x cos of 3x. Always check the angle. So the angle here is 3x. the angle here is 3x. The angle is the same. So we can use sine of 2ax over 2. Okay, so now I'll give you another 1 minute, I think. And then please try to calculate them. 1 minit cukup ke? 2 minit lah saya bagi. Sementara tu boleh saya ikat ni sekejap. So the time start from now. Done. Oh yo, siap dah. Tapi masa saya tak habis lagi. Tak apa, kita tunggu sekejap. Kot lah in case ada yang macam tak siap lagi ke apa ke. Oh, by the way, suara okey ke? Kadang-kadang mic ni dia problem sikit. So nak kena tahu. Suara okey? Screen okey? Ada apa masalah yang tak nampak ke apa ke? Okey, jelas. Alright. Okay. 4, 3, 2, 1, habis. Okay. Done. So now let us continue. Tak breakfast lagi, masuk angin dah perut. You guys dah breakfast ke? Awal sangat kan kelas. Tak dah nak breakfast. Okay, so now the first one we got sine square. So we're gonna use some double angle for them. So sine square of ax, it will become 1 minus cos of 2ax over 2. So we're gonna take the angle for this. We're gonna times them by 2 and then divide everything by 2. So it will become 1 minus cos of 2 multiply with 2x over 2 dx. So we're going to simplify a little bit first. 2 times with 2x. So this is cos of 4x over 2. Okay, so factorize the 2 out first. So be extra careful. You have a 2 in your denominator. So it's supposed to be 1 over 2. So ada setengah orang dia keluarkan 2, tiba-tiba jadi 2 je kat luar tu. So no. Referring to what you have inside. So you are supposed to have 2 in your denominator. So bila factorize akan dapat 1 over 2. So 1 over 2 and then integrate 1 minus cos of 4x dx. And then we're going to integrate them slowly. Integrate 1, we are going to get x because this is a constant. So integrate 1, we are going to get x. Integrate a cos, we are going to get a sine. So sine of 4x over the coefficient of x, which is 4. Okay, so it will become 1 over 2, integrating 1, it will become x, integrate cos, so it will become sine of 4x, and then divide them with the constant, which is the constant, divide by the coefficient of x, which is 4. Okay, so x minus 1 over 4, sine of 4x plus with c, and now we're gonna expand this back. So what do you have is 1 over 2x minus 1 over 8 sine of 4x plus with c. Tada, simple je. Miss nak tanya, memang kena letak simbol ular tu juga ke lepas integrate? No. After you integrate, you don't have those ular anymore. Okay, tengok kat sini. If let's say I integrate x dx. So ni yang simbol ular tu kan. Dia sebenarnya dia macam cantik je kan S tu, tapi faham-faham je lah kan. Okay, so integrate x dx. So this is a pair kan. So kena tulis dua-dua. Once you integrate, you shouldn't write down those integral sign anymore. So kita terus je tulis x to the power of 2 over 2, but you have one extra thing, plus c. So sekarang dah tak ada dah simbol integral ataupun dx, tapi dia akan muncul positif c. So kita tukar lah kitanya. Once you integrate, get rid of those integral sign. Kalau dah integrate je, memang kena buang lah simbol integral tu. Sama macam dulu kita belajar masa kita differentiate kan. So sebelum differentiate, letak d over dx, d over dx. Once dah differentiate je, habis dah d over dx tu. Boleh Nat. Kalau tak okey juga nanti tulis Suka hati je aku panggil Nat. Tak kisahlah Nadira. Nanti kalau tak okey juga beritahu Okay. Right, next. So we're going to integrate sine of 3x cos of 3x dx. So not okay. Next. So check the angle again. So 3x, 3x, we got a similar angle over there. So we can use sine of 2ax over 2. Okay, so it will become sine of 2x, 2ax over 2. So kita akan modify. We didn't integrate them yet. No, we didn't integrate yet. But we want to change it into a sign. Sebab kita hanya belajar 3 benda dalam basic. Sine, cos, second square. Only 3 things. So if you have a multiplication between sine and cos, we need to modify a little bit. So that's why we couldn't integrate them straight away. So dia tak boleh integrate terus je. Sebab kita ada hasil darab. Kalau ada tambah atau tolak, boleh. Hasil darab tak boleh integrate terus. So I cannot integrate them directly because this is a product. So that is the reason why I need to modify them first into something that I know I can use some basic rule. So that's the reason why I'm using this one. So sine of ax cos ax is actually sine of 2ax over 2. So I'm going to modify them first into something that I know before I integrate. Okay, so this is actually sine of 2 multiply with 3x over 2. So now I have sine of 6x over 2 dx. And since I have a single sign over here, I don't know how to integrate them. So that's the reason why we are using those double angle. Kita nak tukar pergi something yang kita familiar and then kita akan solve. Okay, so sine of 6x dx, so referring to the formula, sine of ax, you integrate a sine, you're going to get a negative cos of ax divided by the coefficient of x. Okay, so it's supposed to be negative 1 over a cos of ax plus with c. Again, we can use this formula because this is a linear. So formula ni boleh pakai hanya untuk linear. Okay, next. It will become negative 1 over, so the coefficient of x is 6, so 1 over 6 cos of 6x, and then plus with the c. And then, of course, you can easily simplify them. You got some constant in front, some constant inside. So you can easily simplify them. So it will become negative 1 over 12 cos of 6x, and then plus with a c. Done. Okay, so this is something that is quite simple. Now, let us proceed to something else about trigonometric function. So for this one, we are using the double angle formula to modify them into a basic rule so that we can integrate them much more easier. So now, let us refer to the compound angle. So sometimes we have a sine multiply with a cos plus minus a cos multiply with a sine. So kadang-kadang bentuk tu nampak macam complicated. Dia tengok tu je nampak macam sakitnya kepala. Tengok lah nampak macam sakit kepala. But actually if you are using this formula, it will be very easy because we can actually modify them into a basic rule. And then we can integrate them macam macam tu je. Macam most nafas dia siap. But of course you need to know the, how to say this, the trick and the tips bila nak guna. So kalau macam tadi saya kata bila sama angle kita akan pakai double angle tadi tu kan. Bila ada hasil darab sine dengan cos, angle dia sama, so we gonna use double angle formula. So for this one, what happened is that you have a sine and a cos, cos and a sine. So this one, you're going to use the compound angle for them. So this one, cos, cos, sine, sine. Again, a compound angle for them. It will be very easy after that. So this one, kalau kata kita ada sine darabkan dengan cos dan tak ada kawan sebelah. Kalau macam ni, dia ada tambah tolak cos dengan sine lagi. Yang ini dia saja, sine dengan cos. But if you refer to the angle is not similar for this one. So sebab tu kita tak boleh pakai formula yang sebelum ni lah. Angle dia tak sama. So that is the reason why we are changing them into this one, this formula. So half sine of A plus B plus sine A minus B. And then cos A, cos B, again, the angle is not the same. So I'm going to use this formula. Cos of A plus B plus cos A minus B over 2. And then sine A, sine B, again, the angle is not the same. So we're going to use this formula again. Kalau angle dia sama macam mana? Dia akan jadi sine square lah kalau angle sama. Yang second ni pun, kalau kata angle sama, jadilah cos square. So yang itu back to the previous one. Yang ini untuk angle yang tak sama. Okay, next. Okay, so find the following integral. So we have sine of 3x, cos of x dx. And then another one, we have cos of 5x, cos of 2x minus sine of 5x, sine of 2x dx. So now, the tips and the trick. The first one, you have a multiplication between sine and the cos. Check the angle. So this is 3x, this is x. Is the angle similar? Kalau similar, we can use double angle. But the angle is not similar. So that means we must use the formula yang dekat bawah tu, yang ada A plus B tu. Panggil apa lah? Factor formula kot. Tak ingat lah nama dia. Tapi that thing, A plus B, those A plus B thing. And then for the second one, we have cos, cos, sine, sine. So we got a pair over here. So this is 5x, this is 5x, cos 5, sine 5, cos 2, sine 2. So I know this is definitely cos A plus B. Yang ni cos A plus B lah. Okay, so now I'll give you a few minutes for you to refer to the formula. Do read the formula very, very carefully and see what do you want to use. So yang ini saya pun bagi masa 2 minit jugalah sebab nak berfikir sikit. So 2 minutes starting from now. Apa nak kata? Okay je Miss panggil nak. Okay. Oh, by the way, has everyone key in their attendance? Don't forget to key in your attendance. Oh, almost 1 hour now. Time flies. Cepat gila masa lalu. Dekat habis dah sejam. Habis dah. Oh, ramai yang dah habis bateri. Tiba-tiba dah kurang lah. Tadi saya ramai. Okay, so we got 10 seconds to go. And then we're gonna check our answer. 5, 4, 3, 2, 1. Okay, so now let us check our answer. Okay, so the first one, we have sine of 3x cos of x. So we're going to use the formula for them. So it will become sine of a plus b plus sine of a minus b. So you simply refer to the formula. So sine of 3x plus with x. So simplify this, it will become 4x plus sine of 3x minus. So it will become 2x. So sine of 4x plus sine of 2x dx. So now tadi kita nampak ada sine dengan cos kan. So nanti macam kita tak tahu. We cannot use the basic rule because we cannot have a multiplication between sine and cos in the basic rule. But once you modify them, you can easily see, oh, I have a single sine plus a single sine over here. So that means we can use the basic rule now. So sebab tu kita akan modify sikit lah, kita nak pakai basic rule. If possible, we do want to use the basic rule as much as possible. Okay, so we are going to integrate sine of ax. So integrating sine of ax dx. So integrating a sine, it will become negative cos of ax over the coefficient of x, which is a, and then plus with c. So that is how you get negative 1 over 4 cos of ax minus 1 over 2 cos of 2x, and then plus with a c. And then of course you're going to expand them a little bit. We got some constant here and there. So expand them and simplify. So it will become negative 1 over 8 cos of 4x minus 1 over 4 cos of 2x, and then plus with a c. So done. Done with A, let us proceed to B. Okay, so we got cos of 5x, cos of 2x minus sine of 5x, sine of 2x dx. So referring to the formula, this is actually cos of A plus B. So cos of A plus B, so you simply take 2x plus with 5x. So it will become cos of 7x. And then integrating cos of 7x. So do you remember the formula? Integrating a cos of ax dx, integrate cos, it will become sine of ax over the coefficient of x, which is a, plus with c. So integrate a cos, it will become a sine. So sine of 7x over 7 plus with c. So 1 over 7 sine 7x plus c, ataupun kalau nak tulis sine 7x over 7 plus c pun boleh jugalah. Benda yang sama saja. Okay, done with this. Okay, so that means I'm done with the first lecture. So we're gonna have a few minutes break first. So sekarang 8:58 kan? Rasa macam tak jadi je 5 minit. 2 minit dah lah. Sampai pukul 9, and then I'm gonna start with the second lecture. So bagi masa rehat sikit, minum air sikit. And then we're gonna start with the second lecture. Siapa yang bateri dah low tu boleh lah kot kalau nak cari nak cari charger. Okay, so lecture 1 siap. Lecture 2. So far okay semua orang? Are you guys doing good with the basic rule of integration? So my advice for the basic rule of integration, tulis dalam satu list dulu. Semua tu kena tulis. Every time you do your integration, always refer to the basic rule of integration. Can I fit this into the basic rule of integration or not? Kalau tak boleh, then we can use this technique. Teknik yang inilah yang kita akan belajar lepas ni. So do check first, can you use the basic rule first? If you can use the basic rule, go ahead and use the basic rule. If let's say you cannot use the basic rule, then we're going to use this technique that we're going to learn later. Sini. Tak tahu arah mana kalau you tengok ni. Sini. Betul lah sini. Dia terbalik dengan saya punya kamera. So if you cannot use the basic rule, refer to this one. Okay. Mesti tak cukup je air ni. Sekejap lagi kena refill. Okay, so it's 9 o'clock already. So we're gonna start with the next one. Okay, so at the end of the lesson, you should be able to find the integral by using substitution method and then perform integration by parts. Let us talk about the truth in the real life situation. So kalau kata real life ataupun kalau siapa yang nak masuk bahagian engineering ke apa kan, saya tahu sebab saya ambil maths engineering lah. The function will not be that easy, to integrate. So we cannot use those basic rule. Maksudnya kita kena guna tanda ular and dx tu selagi boleh integrate lah kan. Selagi you haven't integrate, selagi tu you akan tulis integrate tu simbol dia memang ular tu. Ular dengan dx. Ular dengan dx. Kalau you dah integrate dan benda ni hilang lah. Selagi belum integrate, selagi tu je kita tulis je. Integrate dx, integrate dx, integrate dx. Oh, dah nak pakai basic formula. Okay, so yang bawah ni tak perlu dah lah. Dah boleh pakai formula dah. Selagi kita tak boleh integrate dia, selagi tu kita tulis je. Bawa je dia. Okay, tak apa. Sekejap lagi kita tengok lagi Nat Okay, so find the integral by using substitution method. So those are one of the thing. So sometimes when we see those integral, might be a little bit hard for us to use the basic rule of integration. Therefore, we might want to try to use substitution method first. So we're going to try to use substitution and see if we can change them into something with a basic rule and then we can integrate them directly. So kita guna substitution tu sebab kita nak tukar je. Dia jadi something yang nampak macam basic. So baru kita macam okay, boleh integrate. So perform integration by part. Normally integration by part when we have a function that is multiplied but we cannot simplify them into a basic rule. So dia macam sin dengan katalah kita ada EX, kita ada sin. Macam ni kan nak integrate kan. So kalau dia sin dengan sin, kita boleh pakai formula. Kalau dia EX saja boleh pakai formula. Tapi bila dia EX, sin tak boleh pakai formula. So kita start dekat situ. So that is when we use the integration by parts. So I'm gonna teach you later how do we use substitution and how do we use integration by part. Okay, so find the integral using substitution method. Okay, so this is used to compute the integral of the form. So when we use substitution, we're gonna get its derivative. So that is what it means over here. So when we are using something with a substitution, so once we choose our function, so let's say I'm using gx as my function. So once I use that function, if I differentiate this function, I'm gonna get its derivative somehow. So that is when I use substitution. Okay, so u equal to gx, and then when I differentiate them, I'm gonna get du over dx equal to g prime of x, and then I'm gonna write du is equal to g prime of x dx. Okay, so what happened here is that this one can be changed to fu g prime of x dx. So this is actually du. So integrate fu du. Then it will be quite easy to integrate. So yang ini biasanya kita akan dapat benda yang nampak macam kompleks sikit lah. Kompleks ataupun more complicated. This one should be quite easy to integrate. So you can easily use your basic rule of integration to integrate them. But do remember, since you are using substitution, so it's your choice to use another variable. So don't forget to give back the variable. So soalan tu dalam sebutan X kan, kita yang tukar jadi huruf lain. So don't forget to substitute back what is U, because we're gonna write them down in the form of X at the end. Tapi kena integrate dulu tau. Integrate dulu FU DU tu, dah dapat hasil dia berapa. dah dapat FU tu, and then baru kita ganti dia dalam sebutan X. So U tadi adalah GX, and then baru tambah dengan C. So pastikan what is your aim in order to do substitution. So we want to find a function such that when we differentiate those function, we can get its derivative inside. And then we can easily modify them into something that can be easily integrate. And then once you integrate everything, you're going to substitute back what is X. Okay, so use integration by substitution. So this is the tips over here. Use integration by substitution if the function have your u and your du together. So you can easily find its derivative inside this function. So dalam function tu ada dia dengan derivative dia sekali kat dalam tu. Okay, so let us refer to example 1. So we have 8x plus 3, 4x squared plus 3x to the power of 7 dx. So now, what is your choice of u? Obviously, selalunya kalau if it's for me, I will say always choose something that has a power. So function yang ada power lah. So function tu akan jadi sebagai u. So function ni dia ada power. So I'm going to choose them as my u. Other than that, I can easily see if I differentiate 4x squared plus 3x, I can get the thing in front. So that is how I know I can use substitution for u equal to 4x squared plus 3x. Okay, so if u is equal to 4x squared plus 3x, I differentiate them. I'm going to get du over dx equal to 8x plus 3. So that means du is equal to 8x plus 3 dx. So what happened over here? So I simply change this one to become a u. So this one will become u to the power of 7. And then I'm left with 8x plus 3 as well as dx. But that is actually du. So 8x tambah 3 dx, that is actually du. So I can replace everything with du. So it will become u to the power of 7 du. So instead of looking at them like, oh my god, this is so hard to integrate, suddenly it becomes something that is very easy to integrate. U to the power of 7 du. So for this one, we can actually use a power rule for them. So adding 1 to the power, divide by the new power, and then plus with c. So it will become u to the power of 8 over 8 plus c. But one thing to keep in mind, the question is in terms of x. So it's your choice to change it to u. So go back and substitute what is u. U is 4x squared plus 3x to the power of 8 over 8 plus c. So yang ni kalau perasan dia sebenarnya kalau ikut kan kita boleh pakai formula yang f prime fx to the power of n tu kan. But sometimes we don't really remember that formula. So masa tu kena pakai substitution lah. Okay, next. So this is the first example. Oh, should I go this example again? Tak apalah, kita go proceed the next one lah. Okay, so now we got 6x plus 5 e to the power of 3x squared plus 5x dx. Okay, so I'll give you one tips. If you have an exponent, you always need to refer to the power of the exponent first. Check the power for the exponent. If you have something that is not linear, that will be quite nice if you choose that one first as your substitution. So in this case, e to the power of 3x squared plus 5x. So if I look at the power, this is not a linear. So it will be very nice if we can use substitution for them first. But what happens if I let u equal to 3x squared plus 5x? Can I get the term in front? Let us see what happened. Okay, so now u is equal to 3x squared plus 5x. If I differentiate them to get du over dx, it will become 6x plus 5. And if I'm making dx, du as the subject, so du is equal to 6x plus 5 dx. So this one, instead of having something that seems a little bit complicated, so I can easily change this one to become e to the power of u, and then 6x plus 5, and dx, this is actually du. So I can write them down as integrate EU, DU. So instead of seeing them something complicated, it will be something that is quite easy, integrate EU, DU. So this one, do you remember we haven't integrate them yet? We simply modify them into something that looks like basic rule of integration so that we can easily integrate them. So we haven't integrate them yet. So jangan lupa lah simbol integrate dengan DU tu kena ada sekali lah. Okay, so now we're gonna integrate e to the power of u. So sekarang senang lah sebab exponent kuasa dia dah linear. So we're gonna copy down the exponent and then divide by the coefficient of u now. So coefficient of u, depan u ni nombor dia 1 kan. So we're gonna divide by 1. So it will become EU plus C. And then the question is in terms of x, you are the one who changed it to x. You are the one who changed it to u. So go back and change it back to x. So u is 3x squared plus 5x. So substitute back. So it will become e to the power of 3x squared plus 5x plus c. Tada! Simple sikit lah kiranya. Okay, next. Okay, so this one. Integrate ln x over x dx. So this time I'm not going to help you. So I'll give you a few minutes for you to try them first and see whether can you guess your u correctly or not. Or should I help you a little bit? Never mind. I'll give you a few minutes for you to try first. Let's see. Can you get? Can you guess what is the u? So I'll give you around 3 minutes for you to try them. Try to integrate. Can you integrate them or not? So 3 minutes starting from now. Cubalah tengok. Boleh faham ke tak boleh faham? Kalau dah siap boleh tulis kata dah tau. Tapi seronok juga 2 jam direct je. Senang. Banyak sikit boleh cover. Satu minit lagi. 1 more minute to go. Lepas ni breakfast. And then siapkan kerja. Dan huyo laju. Oh, berpasal screen dia punya ni tak white eh. Takut aku. Okay, so now let us see. Do you get them right or not? Okay, so my advice, if let's say you do have something with a fraction, I would advise you to separate them first. What do I mean by separate is that you can write them down as 1 over x ln of x dx. It will be much more easier if we can see them in the form of product daripada nampak dia dalam bentuk bahagi kan. Saya rasa kalau nampak dia dalam bentuk produk lagi senang lah. For me. Okay, so now let's see if you get your u correctly. Let's see what do we need to have as our u. Obviously, you need to have your u equal to ln of x. So u need to be equal to ln of x so that if we do differentiate ln of x, we are going to get 1 over x. So du over dx is 1 over x, and then du is actually equal to 1 over x dx. So this is the reason why I asked you to separate them into two, so that we can easily see this ln of x is actually u. In the meantime, 1 over x dx is actually du. So I can easily write them down. So instead of having ln x over x dx, I can write them down as integrate u du. And integrate u du, oh senang gila. Integrate u du, it will become u square over 2. So it will be something that is quite simple. So we can easily integrate them. Integrate u, or we can use power rule, add 1 to the power, divide by the new power. So it will become u square over 2 plus c. And then substitute back, what do you know about u? U is actually ln of x. So this is actually ln of x square over 2 plus c. Done. Okay, next. Okay, so we have integrate 4x cubed cos of x to the power of 4 dx. So this one might not be that obvious. So you might need to test a little bit. What do you want to use as your u? So kadang-kadang kena fikir sikit lah. Okay, so what if I'm using 4x cube? So kalau yang ini sebagai u, nanti differentiate tak dapat cos. So cannot lah, reject. If I'm using cos, if I differentiate a cos, I'm supposed to get a sine. But I don't have any sine. So no, not a cos. But what about x to the power of 4? If I let u equal to x to the power of 4, can I get everything else? So the answer is yes. So you can choose u equal to x to the power of 4. So choose u equal to x to the power of 4. Then du over dx is simply 4x cubed. That means du is equal to 4x cubed dx. So now this one, we can easily change this one to become cos of u, and then 4x cubed dx can be changed to du. Okay, so satu tips kita try satu persatu. Satu lagi tips lah. My tips. Normally if I see a cos, tapi benda belakang cos tu bukan linear kan, normally that one will be the first thing that I try. Biasanya lah. If let's say I have a cos and then the function behind the cos is actually not a linear, that will definitely be my first guess. What is the u? So that is for me, my tips. Okay, so now du is equal to 4x cubed dx. So when you integrate them, so we're gonna simplify them first to change it into something with u. So it will simply become cos u du. So now we're gonna integrate them. So tadi kita just modify je, kita just tukar je. So pastikan simbol integral tu ada lagi. So do make sure don't get rid of the integral sign yet. Now you integrate them, then get rid of the integral sign. So integrating cos, it will become positive sine. So positive sine over coefficient of u, which is 1. So sine u plus c. So just in case you couldn't remember, integrate cos of ax dx. So this is actually sine of ax over A plus with C. Okay, so now sin U plus C, can we stop? The answer is definitely no, 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 no. So you have to go back and substitute. U is actually x to the power of 4. So substitute back. So it will become sin x to the power of 4 plus C. Oh, macam terror. Next. Okay, so this is example 5. Sin to the power of 4x cos of x dx. Okay, so now let us see a little bit. So yang ini kalau ikut, kita tak boleh pakai yang kita belajar tadi masa 1.2 yang kita boleh modify kan. Memang kita ada sin dengan cos tapi kita ada power. So since we have a power for the sin or the cos, we cannot simplify yang guna compound angle tadi. Compound angle ke, vector formula ke, those things we cannot use them because we have a power which is not 2 over here. So tak boleh pakai yang itu. So what can we do? We can actually modify this. So instead of having sin 4x, so I can actually write them down as sin of x to the power of 4 and then cos of x dx. So kita boleh modify sikit lah. And then let's see. Okay, so my other tips. Okay, so if you see a function that has a power, but the function is actually not a linear, then that is the first thing that I'm going to use substitution for. So itu benda yang pertama lah saya akan try. Okay, so I'm going to let u equal to sin of x. So differentiating u, it will become cos of x. So du over dx is cos of x. And then you can easily see your du. Du is actually cos of x dx. So that means integrating sine to the power of 4 dx, sine to the power of 4x cos x dx, it will become integrating u to the power of 4 u, and then integrate u to the power of 4 du. Ya, kacang. Adding 1 to the power divided by the new power, so it will become u to the power of 5 over 5. Okay, so u5 over 5, substitute back. What is u? U is sin x. So this is sin to the power of 5x over 5 plus c. Done. Okay, so now let me show you one thing. If let's say you are choosing them wrongly, so substitution ni, we must choose the u very, very carefully. What happen if you choose them wrongly? Okay, so let's see. Kalau yang ini pilih sin kan, katalah saya pilih cos. Okay, so u is equal to cos of x. So that means du over dx is equal to negative sin of x. So du is equal to negative sin of x dx. So mungkin akan ada orang yang sebab ini kuasa 4 kan, dia pun nak kuasa 4. Nak kuasa 4 macam ni. So yang ini tak boleh lah. Kalau nampak macam ni saja, dah tahulah dia tak boleh guna. This substitution doesn't work. So that means you have to choose another one. Sebab kalau kita ada du tak boleh ada kuasa. Tapi kalau nak darab tak ada masalah. Contohnya macam du equal to negative sin x dx. Saya nak positif saja. So saya boleh letaklah negative 1 du sama dengan sin of x dx. Kalau setakat darab dengan constant tak ada masalah. Ini constant. Yang pasti du tak boleh power. Tak boleh power kat du. Suka hati je aku tukar bersama u. Never mind. Okay, so in du, you cannot have a power for the du because du actually represent that we're going to integrate them. So we cannot have du to the power of something. So always make sure that if let's say, once you choose your u and you end up with du to the power of something, don't freak out. Tak payah macam nervous ke apa ke. Don't freak out. You have something else. So go and choose something else. So ada banyak lagi benda. If plan A doesn't work, we still have plan B. Plan B doesn't work, we have plan C, plan D, plan E. We still have all the alphabet up until Z. So kalau Z tak boleh guna, kita boleh guna alpha, gamma, beta and etc. Okay, next. So I'm done with the substitution part. So substitution part, always make sure when you are using substitution, so something that seems a little bit complicated, it should be something that is quite easy to integrate using the basic rule of integration. So that is our aim. When we change it into something in terms of U, it should be quite an easy thing to integrate. If it still seems a little bit hard, then perhaps that technique is not the most suitable for them. You have to use another technique. Okay, so another technique that we're gonna learn is how to perform integration by parts. So the formula for integration by part is that integrating u dv is equal to uv minus integrate v du. So we need to be extra careful when we are using integration by part because we have to choose our u as well as our dv carefully. So we need to choose u and dv carefully. So we're gonna write down u on the left hand side, dv on the right hand side. I do find it will be much more easier if I write u dv, and then what happened is that I'm going to differentiate u to get du. And then I'm going to integrate the v. I'm going to integrate dv to get a v. So this one, differentiate. This one, integrate. So you're going to differentiate one side, integrate the other side. And then you're going to use the formula u times with v minus v times with du. So u times v du, but do make sure we have to integrate v du. Okay, so the rule of the thumb is that whenever we are using integration by part, our VDU should be much more easier to integrate compared to whatever we start with UDV. So masa kita start UDV tu, it might be a little bit complicated, but when we are using VDU, it should be quite easy to integrate. Maksudnya kita boleh pakai basic lah. If we cannot use basic, then most likely you have to use another integration by part. So tengoklah kalau boleh pakai basic tu settle lah. Kalau tak pakai basic juga, dan mungkin kena pakai integration by part another time. One more time. Sometimes you have to do integration by part twice. So tapi sepatutnya the degree of difficulty is lower compared to whatever we start with. So sepatutnya dia dah kurang sikit lah kepayahan dia tu. Okay, so now 3 steps to perform integration by part. The first one, you have to identify your u and your dv. So identify them correctly. You must choose your u and your dv correctly. The second one, you need to differentiate your u, and you need to integrate your dv to get du and v. And then the third one, you have to substitute into the formula, and then you got to solve them. Okay, now the technique of integration by part. How to choose the u, choice of u. So normally we're gonna use something called the Lopet. Lopet code. Okay, LO actually stand for a log. So if just now we have a u and a dv, right? So u ni benda yang kita nak differentiate. So bila kita nak differentiate, kita akan cari benda yang paling senang untuk kita differentiate. So that is why we start with a log. So we're going to start with a log first. So you're going to see the term. If we have a log, then those log will become the u. Everything else will become dv. The second one, p stand for the polynomial. So you might have x squared, x cubed, and etc. So those are polynomial. So log, polynomial. E stand for exponential function. So for example, e to the power of 2x, e to the power of 3x, and so on. So those are exponential function, as well as a to the power of x. A kuasa x pun boleh juga. Okay, and then t, trigonometric function. So trigonometric will be the last one, because if we differentiate a trigo, we're going to get another trigo. So normally we want to have something that is much more easier. So that is why we put our trigonometric function to the last one. Okay, so logarithmic function, polynomial, exponential, and trigonometric. So lopat. Okay, so now find, integrate x, ex, dx. So now we cannot easily separate them. Why? Because we have a multiplication. So kita ada hasil darab between the x and e to the power of x. So that means I cannot use the basic rule, I cannot separate them into two. If I want to use substitution, kuasa E ni dah linear, so I don't see any point of me using substitution. So that is the reason why I'm using integration by part. So integration by part, we're going to separate them into two. What is E? E is actually a polynomial. E pula, X. What is X? X is actually a polynomial. E to the power of X is actually a exponential function. So we're going to refer to low part. Who comes first will become our U. So log, tada, P. So we got a P first. So P will become our U. And then dV will become the rest of it. Okay, so P is X, E is E to the power of X. So U will be equal to X, dV will be equal to EX dx. So nanti kalau ada highlight kan, once you highlight your X, whatever you have left, that one will become your dV. So highlight benda yang kita akan ambil sebagai U, the rest it will become dV. So now U, we're going to differentiate them, differentiate U, du over dx, it will become du over dx equal to 1. So du is equal to dx. Okay, so we're going to have du as the subject over here. And then for this one, we're going to integrate them both. So integrate on both sides. So v is equal to integrate ex dx, integrate some exponential function. So integrate eax plus b dx. So this is eax plus b over a plus c. So we're going to copy down the exponent and then we're going to divide by the coefficient of x, which is in this case 1. So it will simply become ex. And then we're going to use the formula for them, u times with v. So u times with v minus v times with du. So u times v minus v times with du. So we're going to write down into the formula. So integrate x ex dx. So this one will become u times with v. So u, v minus integrate v first. So v is ex, du is dx. Okay, so now when we start, we are actually having something with a product xex. But now we only have ex dx and we can easily integrate them. Tadi pun dah integrate kan. So this is actually ex. So it will become xex minus integrate ex dx, and integrate ex dx will simply become ex. So xex minus ex plus with c. Done. Okay, so done with this. Now let us proceed with another example. Okay, so we got x cos x dx. Okay, so now you can choose your u, you can choose your dv. So choose your u and your dv correctly. And then you can easily integrate them by using integrate u dv equal to uv minus v du. Okay, so now let's see what do we have. Okay, so we have x. What is x? X is a polynomial. What about cos? Cos of x. Cos x ni kita baca sekali tau sebab ni angle dia. So jangan baca dia seorang-seorang. Cos of x. Cos of x is actually a trigo. So low part, what comes first is that p come first. So we're going to have x as the u. So u is equal to x. Meanwhile, the dv is equal to cos x dx. So ingat tadi saya kata highlight kan. So ambil highlight. Kalau kita dah highlight x, whatever you have left, that is actually your dv. So benda tu yang tinggal lah. Yang kat belakang tu kalau ada dua color lagi senang. Highlight, highlight. Okay, differentiate u. That will be very easy. Differentiate u. Du over dx is equal to 1. That means du is simply equal to dx. x. And so now what about dv? dv is equal to cos x dx. Integrate them. So integrate dv tu tak payah fikir banyak lah. Terus je dv. So now we got to integrate cos x dx. What about integrating cos? So do you remember the formula? Cos of ax plus b. So integrating a cos, it will become a positive sign. So sine of ax plus b. But then you have to divide them by a plus with c. So we're going to divide by the coefficient of x. Okay, so over here the coefficient of x is 1. So selamat satu kerja lah. So it will simply become sine of x. So tambah c kita tak tulis lagi kat sini sebab nanti bila kita masuk dalam formula dah habis semua integrate baru kita letak tambah c lah. Okay, so now we are going to use our formula u times with v minus v times with du. Minus je, minus 1 sekejap jadi lain pula. U times v, v times with du. So it will become integrate x cos x dx equal to u times v. So x sin x minus integrate of v. So integrate sin x dx. So now it will be something that is very easy, right? So we only need to integrate sine of x dx. Integrating sine, it will become negative cos. So what do you have is x sine x minus negative cos x plus c. So simplify them a little bit. So what do you have is x sine x plus cos x plus c. Okay, so I think I need to remind you one thing. Ni untuk yang memang suka tersalah tulis integral. Okay, this part over here, I haven't integrate them yet, right? So that is the reason why I keep writing down those integral. So tadi daripada dalam kurungan, saya buka je kurungan tu. But now once I already integrate them, then I need to write down the answer as well as plus c. So dah tak ada dah simbol integral ni. The integral is not here already. So we already integrate them. Okay, so done with example 7. So we got 2 more examples to go. I think I should give you some time to do this question. Okay, so we got x ln x dx and then you have to integrate them. This is integration by part. Definitely use integration by part. So I'll give you around 5 minutes for you to try them first. So 5 minutes starting from now. Try them first and then see what do you have. In the meantime, let me go and take some water. How are you guys doing? Okay ke? Ada nampak macam mana nak cari? Done. Okay. Siapa yang Omega Zero ni? Bahaya gila nama macam tu. Saya username dia pelik je. Orang lain saya rasa dia dah pergi cari makan kot. Tengok dah 78 ni. Dah kurang 10 orang. Dia orang pergi breakfast tak aci, tak ajak. Okay, 35 seconds to go and then we're gonna start discuss. Oh, by the way, forgot to say, welcome back to the college. Sebab baru balik kan, lupa nak cakap. Welcome back. Long time no see. Lama tak nampak muka orang. Okay, done. Alright, so now let us continue then. Okay, so I have x. So what is x? X is a polynomial. Ln of x, so we should read them together. So ln of x, this is actually a log. So we're going to refer to Lopat to see which function comes first. So based on the Lopat, so LO comes first. So that means I'm going to choose ln x as the u. For the polynomial, that one will become my dv. Okay, so u is equal to ln x. We're going to differentiate ln x. So it will become 1 over x. dv is equal to x dx. So like I told you before, nanti highlight ln x tu. After you highlight your ln x, you're going to see you have x dx. Okay, so x dx, this one. Okay, so you're going to integrate x dx. So this is x squared over 2. And then we're going to use the formula. So integrating x ln x dx, u times with v. U times v minus v times du. Okay, so it will become u ln x multiply with x squared over 2 minus integrate x squared over 2 multiply with 1 over x dx. Okay, so do make sure to simplify them first before you integrate. So yang ini tak boleh lah, dia ada dua fraction yang separate, tak boleh. So we need to simplify this fraction first before we integrate them. Okay, so it will become x squared over 2 ln x minus integrate x over 2 dx. So now we can integrate them. Integrating x, that was simply adding 1 to the power divided by the new power. So it will become x squared over 2 ln x minus 1 over 2 x squared over 2 plus c. So this is x squared over 2 ln x minus x squared over 4 plus C. Okay, so nak tanya apa? Miss boleh explain lagi sekali tak? Macam mana kita nak tahu boleh guna substitution or by parts? Okay, so normally for me, I always try to use the basic rule first. Every time I see those integral, I try to use those basic rule first. If like say they are not inside the basic rule, kadang-kadang benda tu bukan dalam basic rule kan. So for example over here, I have x ln x. So dalam basic rule saya sama ada saya ada x sahaja ataupun saya ada ln x memang tak ada lah dalam basic rule. So saya ada x je, tak ada x ln x. So basic rule out. If I cannot use basic rule, then sometimes I will try to check if I can use substitution. So normally for substitution, kita kena tengok sama ada kita ada derivative dia atau tidak dekat dalam ni. So if I choose x as my function, then u is equal to x kan. U sama dengan x ni maksudnya u hanya ubah huruf saja, tak jadi apa pun. So do make sure jangan sekali-kali buat substitution u sama dengan x. X plus 1 okay lagi. Tapi kalau setakat u sama dengan x tak berbaloi lah, tak jadi apa. So substitution doesn't work over here. If I choose u equal to ln x, then if I differentiate ln x is supposed to be 1 over x. But I don't have 1 over x inside here, so I cannot use substitution. So guna x tak boleh, guna ln x pun tak boleh. Then therefore I'm going to use integration by parts. Okay, so ini rule of the thumb lah. Biasanya kita akan cari ada derivative ke tak. But with, how to say this, with experience boleh ke? Boleh lah kot. So I learned this when I was 17. So 13 years of experience. Suka hati aku je. Okay, so 13 years of experience. What I will say is that normally I have to use substitution if I got a function. Basic rule tadi kita ada apa? Sin of ax plus b kan. So this is basic. But if I have sin of x square plus 1, then I know this one I definitely need to use substitution. Semestinya guna substitution. Kalau ada derivative, kita guna substitution. Kalau derivative tak ada, dan besar kemungkinan mungkin kena pakai by part. Tapi dari situ boleh tengok lah. Ini dia experience jugalah. Berdasarkan experience juga. Tapi kalau untuk awak, experience tu jauh lagi kan, 13 tahun, jauh lagi. So I would advise you to refer to your basic rule first. If you don't see them inside your basic rule, then do try to use substitution. Check your substitution. So dia kena cepat sikit lah masa fikir tu. If you differentiate them, can you get its own derivative inside? Boleh dapat tak derivative dalam tu? Kalau boleh, go ahead. If you cannot find its derivative, then go to integration by part. Tapi dia kena cepat sikit lah. Lama-lama dia laju sikit lah. Tengok tu je pun dah boleh agak-agak dah. Nak pakai apa. Okay, so done with this question. So that's the end. The last question lah. Oh, sampai 8 je. Saya ingat ada 9. Salah kira Betul tak ada lah Sampai 8 je. Sampai 8 je. Okay, so that means that's the end of the first week, everyone. So I'll see you guys next week. So if let's say next week is online, so I'm going to see you again over here. If let's say next week we're going to see each other face to face, then maksudnya minggu depan kita jumpa dekat DK lah, dekat Dewan Kuliah. So hopefully I can see your face next week. So dah macam dah dekat satu sem kan aja tak nampak muka kan. So it will be quite nice if I can see your face next week. So let us see each other next week hopefully. Okay, so goodbye. Have a nice day everyone. I want to go and have my breakfast. So bye. Welcome. Bye-bye. Have a nice day.